All right, we're going to take a look at lesson 8 here. Direct variation. Now, it sounds worse than it is in that you guys deal with this on a daily basis. It's nothing new. There's just different ways of looking at it. We want to formalize it so that when you see the information, you know what it is. Now, it says A varies with B. In other words, something varies directly with something else. And when we're talking about direct variation, it's always going to be a multiplication. Uh, Anybody ever put gas in the car? That number that you see on the sign when you pull up to it, where do I want to go? Okay. Do you want to go and put gasoline in for 219 or do you want to put it in for 229? You guys want to put it in for the more expensive one? Or you want the cheaper one? Oh, yeah. All that is up there is the constant of variation. How much you pay depends upon how much fuel you put in the car. That's all it is. Okay. We've got some that are, more common. Circumference of a circle varies as the radius. You've heard of pi r squared, correct? You've heard of circumference is pi times r. Pi is just simply the constant. It doesn't change. We just multiply it by the radius. Now, resistance is directly proportional to length. When we talk about electronics and electrical circuits, the longer the wire is, the more resistance there is there. Water produced very directly as the amount of hydrogen burned. Chemistry. We know exactly what these things are because they are going to be in this form. Just think, the more of something that you buy, the more of it cost you, right? So, let's take a look at this one. It says the number of seconds varies directly as the number of minutes. 120 seconds passed, 2 minutes have passed. If 300 seconds have passed, how many minutes have passed? Well, how many seconds are in a minute? How many seconds in a minute? 60 last I checked, right? So, if we have this as A is equal to K multiplied by B, okay? If I've got 2 minutes and 120 seconds, I get 120 out here is equal to K times 2, right? Divide by 2, and I get 60 is equal to K. So that's the constant of variation. That's all it is. Nothing that you don't know. Okay. So if I got 300 seconds, how many minutes is that? 9. So we'd have 300 is equal to 60, and we're looking for the number of minutes. Divide by 60, and we end up with 5 is equal to the number of minutes. It's just how the math works out according to the formulas. You already know how to do it. You've had enough experience with it. Try this one. Distance, rate, and time. How long does it take to get the TR from here? An honest half hour if you're doing things correctly. If you do it in 20 minutes, depending upon where you're going in there, you're pushing it. 17 miles from point to point. If you're going 60 miles an hour, theoretically you should be able to do it in 17 minutes, correct? But depending upon where you leave, you have to accelerate, decelerate, stop, wait for traffic. Right? If there's a train there, you should stop, correct? Be a good idea. Huh? There are times. And it depends upon which way you go. I mean, do you turn straight and come in the other highway, or do you keep on going and wait forever over by petrol pump? It all depends. But, well, theoretically, if you actually do it in less than 17 minutes, you're speeding. Okay. That's just a mathematical fact. So, a motorized scooter can travel 10 kilometers in 30 minutes. How far can the scooter travel in 45 minutes? Well, how fast is he going? We don't know. But remember, we've got the formulas. Distance is equal to the rate multiplied by the time. It's in the form of the ratio. Or I should say ratio in our... Yeah, no, I lost what I was talking about. What did you say that when you lose a word? Constant of variation. There it is. So, distance, 10. Rate, don't know. Time, 30. Divide both sides by 30, divide by 30, and I end up with what? 1 over 3 is equal to R. Does that even make sense? So, but what does that 1/3 mean? That's 1 kilometer in 3 minutes. Do we even think in those terms? What should I really have down here? What should I have? What do we always measure things in when we're dealing with speed? Hours. Okay, so I need this in hours. How many minutes in an hour? 60. What do I got to multiply 3 by to get to 60? Try 20. So if I multiply each one by 20, I get 20 kilometers, per 60 minutes or 1 hour. So I'm going 20 kilometers per hour. Well, if you think about it, 10 kilometers in 30 minutes, what part of 30 minutes is, what part is that of an hour? Half. So if I double it, I should be able to go 20. That's exactly what we got. How far can you go in 45 minutes? Well, if I'm going 20 kilometers per hour, so distance would be equal to 20 kph, right? What is 45 minutes of an hour? How much? 3/4. So we multiply it by 3/4. Well, that goes into there, and I get 5. 5 times 3 is going to be 15. So that means I can get to go 15 kilometers. Now, this is what I mean is by you should be able to deal with this pretty easily. 45 minutes. What's half of 30? 15. What's half of 10? 5. So if I go for another 15 minutes, I should be able to go another 5 kilometers, correct? Isn't that just what I got down here? There are a lot of ways of thinking about this stuff. You've already done this and are experiencing a lot of it. Okay? So when you look at it, put it into terms that you're accustomed to dealing with. Cost varies directly as the number of purchases. Okay? If 12 items can be purchased for $78, how much would 42 items cost? Now, when I get things like this, I tend to set them up as a ratio because the other way of dealing with it is really a pain. Okay? So, ratio. Okay? 12 over 78. Now I got 42. Now, there are a couple of things that you got to keep in mind when you're setting this stuff up. This stuff going across this way must be the same. Okay? If I'm talking items here, I want items over here. This has to be the same. If I'm talking dollars here, what am I going to get down here? Dollars. Now, this going this way must be the same. Well, how are they the same? They are talking about the first set of things, right? Those two go together. So does this here have to go together as well? Okay. So there has to be some commonality with this. Now, the rule that I got, multiply on the diagonal, divide by the other number. So, if I do that, I end up with multiply on the diagonal. Those numbers are diagonal to each other, so 42. Clear that out. 42 is going to get multiplied by 78. Divide that by 12. So I should be able, it would cost me then $273. Does that seem reasonable? Well, let's see. 12 would be 78 bucks. If I double that, that'd be 24 for 140 or close to $150, right? If I get another 12 on that, that's going to be 48, and add another 70. It seems about right. Close. Ballpark. But that's all you have. Number of railroad ties used in a section of track is directly proportional to the length of the track. Well, the longer the track is, the more railroad ties you need, right? If 15 ties are used in a 30-foot section, how many ties are used in a 50-foot section? Okay, set it up the same way. We'll put 15 over 30 is going to be equal to, I don't know, over 50, correct? Because that's the section. So now it's 15 times 30 divided by, or 15 times 50 divided by 30. So 50 times 15 divided by 30, 25. Are there other ways to do this? Well, heck yes. Could I simplify these two guys? I could simplify that down to be 1, and that's going to be 2, correct? 1/2 is 25 over 50, 1/2. It's not that difficult. Chemistry. Now, if I've got to solve this, again, I'm going to use the ratios. Why? Because it's set up so nicely for it. All I have to consider is that this is a fraction, that's a fraction, this is the equals. That times that divided by that will give me that. That's all it is. So that means that I would have 236 multiplied by 315 divided by 295, and I get 252. Okay. So what happens if I don't necessarily agree with that? Could I use this first set here as well? So if I go and take 315, multiply it by 224, divide that by 280, do I get the exact same number? Yes. Okay. So as long as the ratio is holding out, it's great. Right. As long as that happens, great. Now, what happens if I wanted to do it the equation way? If I put in the temperature, I get out the volume, right? So that means some temperature, correction, wrong way around. That means that volume is going to be equal to the temperature multiplied by some number. I have no idea what that number is. So if I put in 224 is equal to 280, by the way, that K is not the same as this K. Divide by 280, divide by 280. So we end up with, calculator, 224 divided by 280, and I end up with 0.8. So 0.8 is equal to K. So that means I should take 315, multiply it by 0.8. Is that going to work? 315 multiplied by 0.8, 252. The nice thing about this is there's more than one way to get there. You just got to take the time and look at it, which is the best way to go. Is it a good idea to know what the constant of variation is? You know, it's like the unit price. That helps for certain things. If you're buying something that costs big dollars, if you're buying a box of Twinkies for $2.99 and you want 10 boxes of Twinkies, so then you got to multiply $2.99 times 10, right? That works. So let's give this a look. Okay. So I'm going to give you a minute or so here, and I want you to do practice problem A. So let's break these down. Eli, what you get? 5? 5. Tell you what, you can work for me this winter. I'll pay you 1,000 an hour to do my shoveling for snow. Yeah, I'll pay you 1,000 an hour. Sound like a deal? Okay. Oh, would you expect me to say exactly what that 1,000 is in the contract? No. 1,000 snowflakes. I'll even let you pick them. This is where labeling comes into play. What are we talking about here? Feet. So we got to make sure that we put in the feet. Okay. The number of inches varies directly with the number of feet. If a board measures 36 inches, it measures 3 feet. Okay. I honestly like dealing with it like this. If I can set it up as a ratio, it's always a lot quicker for me. Okay. Especially if I only need to figure out what one thing is. Okay. Let's see. So we got 60 inches. So 60 inches would go down here. So that times that divided by that. So let's go to that. So we've got 60. No, not what I want. 60 times 3 divided by 36, and I end up with 5. So there we go. Okay. Like I said, I tend to use this. I will identify when I want to use the other way, but this takes care of it most of the time. So here we go. Give you another minute or so. Give this one a shot. David, what you get? 8. Okay. 8. So you're going to come and shovel for me, huh? 8 what? 8 cups. Okay. Now, it says the number of cups varies directly with the number of fluid ounces. In 5 cups, there are 40 fluid ounces. Now, when you open up the cookbook and you're actually going to do some cooking, would it be a good way to go and identify 5 cups, 40 ounces? Is that what you'd want to see? You'd want to know how many ounces are in 1 cup, correct? So in this case, knowing what that unit multiplier is, or the constant of variation, would be handy. So if 40 is supposed to be equal to k over times 5, divide by 5, divide by 5, 8 is equal to k. So we would not need to know that there are 8 ounces in each cup. So 1 cup is equal to 8 ounces. Now, say I've just got that. I know what that is. I could set my ratio up again with that idea and just have it, 1 cup, 8 ounces is equal to blank cups over 64 ounces. So that times that divided by that. Last I checked, 64 divided by 8 was 8. So it's 8 cups. Okay. I could have even used the 40 if I wanted to. Instead of that, the 1 and the 8, I could have said, okay, I have 5 up here, and I had 40 down here. So I could have used a calculator, and it would have been 64 times 5 divided by 40. And I still got 8. If you set it up properly, no matter which method you use, you'll get the right answer. Okay. So, here we go. Everyone near and dear to your hearts. So I'll give you a minute or so on that one. All right, so Damien. Huh? Why? Ah. So, okay, well then tell me what I'd have to set up. Well, if I put 10 gallons up here, I could put 25 down here, right? And then I could have 15 over here, and then I would get my dollars down there, right? By the way, if I buy 10 gallons of gas for 25 bucks, how much is it per gallon? 250. So it's 250 a gallon. Okay. Just for the sake of argument. So that means it'd be 25 times 15. And you did put it early, but again. 25 times 15 divided by 10. So that means it cost me $37.50. Well, if it's $2.50 a gallon and I took 2.5 times 15, I get $37.50. Now, this is where everybody Thanks. Yeah, not a problem. 37.50. How much is that per mile? How much does it cost per mile? Well, it depends upon what your gas mileage is, right? So, pickup, how much you get? What's your mileage on the pickup? 17 miles per gallon. Okay, so for every gallon that I can get, and if I'm going 15 gallons, oops. So if I've got 15 gallons of fuel times 17 miles per gallon, right? How far should I go? 255 miles? Okay. So I can get 255 miles. Okay. So how much does it cost for that? So what is the price per mile? So how much did you pay for those 15 gallons? 37.50, right? So if it's 37.50, divide that by 255. So that means you're basically you're looking at 15 cents a mile. That doesn't sound bad, does it? Now if I pull my car out, my car averages about what is she at? About 42 miles to the gallon right now? It does. I got a Ford C-Max. 42 miles to the gallon. Well, yeah, the way you drive a 10, I can understand that. But no, if I get her out on the open road doing 65 miles an hour, she'll cruise at a nice 42 miles per gallon. Usually right around here, I get 40 miles to the gallon. So I'll use 40 miles to the gallon. Yeah, gas electric hybrid. So 40 miles to the gallon. So if I had 15 gallons, multiply that by 40, how much do I get? How much? 600 miles. And how much did that gas cost me? 37.50. So if I go and take 37.5, divide that by 600, I end up with 6 cents a mile. So now, obvious thing here is that, well, you ain't going to pull the boat with that. You ain't going to take it hunting. You're right, you ain't. But I got to drive down to the cities tonight. Am I going to take my pickup or am I going to take that? Take what? The pickup is, yeah. But hey, quit picking up my phones. But I'd take the C-Max. Why? 6 cents, per mile to drive it. So, but I wouldn't use it for if I got to go and haul a bunch of lumber, or if I got to pull a boat or something. That I wouldn't use it. So, let's try this. Okay. Give you a minute or so and give that one a try. So cool. What'd you get? 5 bags. Does that seem reasonable? Because 4 bags will get me about 108, so yeah, it seems reasonable. But 2 over 54 is going to be equal to what out of 135? And like I said before, I tend to use the ratio way of doing this because it's just a lot faster. 2 times 135 divided by 54. I end up with just 5. Exactly. Okay. I want to take a look at this one here. So, what I want you to do is I'm going to give you, I'll give you about 30 seconds here, and I'll do E, and then we're going to go over the other two. So, Jordy, what'd you get? 60. Did it really even take that much to figure that one out? Not really, because if you had noticed over here, 20 gallons, 40, it doubled it. 30 should go to 60. Now, in order to help us out here a little bit, we're going to use the graphing calculator to deal with this. Now, I've got the instructions up there. It's on the stat plot, but I'm going to go through and show you on here. So I got edit, enter. I can put the coordinates in. Now, you got to figure out which one is the x, which one is the y. Okay, what relates to that? So, volume is going to be equal to the length of pipe. So volume is the output, length is the input. So that means volume is going to be y, length is going to be x. So what I'm going to do is I'm going to put in 20, 30, 40. Then up here, I am going to put in 30, 45, and 60. Now, if I want to plot these points, I'd hit second, y equals. My plots are already on, so that's a good thing. But I'd hit this, make sure that the on was on. Then I would go to the window. Let's see. Minimum. Well, we're putting things in going up to, let's see, yeah, 0 to 100. So I'll put in 0, we'll put in 150, okay, for the pipe. Y minimum, 0 gallons. Oh, we'll move that up to 100. That sounds reasonable. So, if I go and hit a graph, whoops, sorry, clear that out. So I've got the points going up like that, right? So I got a nice little graph there. On G here, it wants us to write the equation. If I go to stat, I go to calc, and I go down here to number 4, linear regression. What this is going to do is take that information and create the equation for me. So I click on that, hit it again, and I've got the equation right there. So that means my equation is y is equal to 1.5 x plus 0. Okay? Or in this case, volume is equal to 1.5 multiplied by the length. Okay. So if I go back to my y equals, I can put that in now. 1.5 x, and I tell it to graph. Now I see that it goes off the chart there, so I better make the window go a little bit higher. So how about we go down? I'm going to move that up to 250, and now I'm going to tell it to graph. Changes it a little bit, draws it out there. Now if I hit the trace and I put in 100, that is, I am told that the volume will be 150 feet. So by coming up with that equation, it makes life a lot easier to go and do a lot of other calculations. So there you go.